Okay, hi and welcome to this video on dilation. So in this video we're going to be talking about dilations to x values, right? So a dilation tells us to multiply, right? So that means we're multiplying something by a value, and that something is usually the x, right? So we're going to multiply x. And remember from the translations video, if you watch that, that anything that we do to the x values is going to result in some change in the horizontal direction, right? So our change is going to be a horizontal change. Okay, so in this case, we can see that we have y equals the absolute value of 4x. Okay, well, what kind of function is this? Well, you probably guessed that it was absolute value. All right, so then now we want to know what's going to happen to it, or actually the parent function is y equals x. Okay, so the only thing that's changed is the 4. So what is the 4 going to do to this absolute value parent function? Well, the 4 is basically going to shrink it. So remember that we talked about x usually being the opposite of whatever you're doing. So instead of it seems like the 4 would multiply, but it's actually going to shrink it, because what you do is you take your x values, right, and you multiply them by the reciprocal of whatever you're doing to x. So it becomes the opposite, and the reciprocal of 4 over 1 is 1 over 4. All right, so let's see how that applies to our graph. Okay, so maybe it's a little much now, but let's go ahead and graph the function. So we're going to graph 0, 0. The absolute value has a 1-to-1 relationship. So we know our values. Our function will look like this because our values are the positive of whatever our x values are. That's what our y values are. Okay, so let's zoom in so we can see how this transformation is going to apply. All right, so since all of my x values are going to be are going to shrink my function, right? So if x is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, we're paying attention to the x values. So if the x values are going to shrink, they're going to shrink by a factor of 4. So that means they're being divided by 4, which is the same thing as multiplying by 1/2. So if x is 1, right, now it's going to be 1/4. If x is 2, now it's going to be 1/2. And so let me make that 1/4 a little clearer. So that's there. If x is 4, right, it's now going to be 1. So that is going to come over here. Let me make that 1/2 a little clearer. The same thing on the other side. If x is 1, it's going to go to 1/4. If x is 2, it's going to go to 1/2. If x is 4, it's going to go into 1, right? So basically, we get something that looks like this, right? And then another way we can test it, if x is 8, right, it's now going to become 2, so it should be passing through that point. And then the same if x is -2, then it should be going through 8 as well. Okay, so we get an absolute value function that looks like this. So this is y equals the absolute value of 4 inside the absolute value x, and this one is y equals the absolute value of x. So we can see that change, that it may look taller, but actually it's just been squished in. So all the x values have been squished in. Okay, so now let's go to y equals 1/4 x squared. Okay, so how does this one apply? All right, so for this one, we can tell that this function is quadratic. And so the quadratic parent function is y equals x squared. Okay, so let's make our prediction. We have a 1/4 that's being applied to that x value before we square it. So what's going to happen with that? Well, basically that's going to stretch it. So it's going to stretch horizontally, okay, by a factor of 1/4. Okay, so it's going to stretch horizontally by a factor of 1/4. Well, what does that mean? Well, let's graph the parent function first. So we have 0, 0, 1 squared is 1, 2 squared is 4, and then -1 squared is 1, and then -2 squared is 4. So here's our parabola, our bowl, and make sure it looks like a bowl. Right, and if you want to extend it up further, then we can go all the way to 3, right? 3 squared is 9. And so that one should be passing through those points. Okay, so this is our parent function, y equals x squared. All right, so in orange, we're going to graph our new function. Well, what's going to happen? So remember, we're paying attention to the x value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so all of those x values are going to multiply by 1/4. Okay, so remember that it's being stretched horizontally. Well, I'm sorry, they're going to multiply by 4. Well, where do I get 4? Well, basically you take the reciprocal because it's always the opposite of whatever you're doing to x. So the reciprocal of 1/4 is 4 over 1. So let's multiply 1, 2, 3, 4, right? And then, so this point, or this, I'm sorry, this point, which is at 4, right, at 2, 4, well, if you multiply 2 by 4, it's going to become 8. So now this point is going to be at 8. And so the same thing is going to happen on the other side, right? This point is going to become -4, 1. So 1, 2, 3, 4, and then 1. And then this point, which is at -2, is now going to become -8. So that one will be, looks like right here. Yeah, so that's -8. Okay, so the 0 point is going to stay the same. So now our function is going to look much wider than the function that's already there, right? So it looks like a bowl, okay? So it's still symmetric on both sides, but now it looks like a bowl, a wider bowl, okay? So we can see that it's been pulled out vertically. So it's kind of like you're taking the handlebars or each side of the parabola and you're pulling it out. All right, so now let's look at what happens with an exponential in that case. Okay, so we can see that this one is exponential, so y is equal to 3 to the power of x would be the parent function. Why? Because you look at the base. Okay, well, where is the transformation being applied? Well, that's going to be on the 2. So what is the 2 going to do to this exponential function? Well, remember we said that whatever you would think would happen to x is actually going to be the opposite. So instead of 2 stretching it, 2 is actually going to shrink it. So this one is going to shrink or squish it horizontally. So shrink horizontally by a factor of 2. So now let's see what that looks like. Well, first we have to graph the parent function. So going back to green, I know that 3 to the -2 would be 1/9, right? So if you've forgotten how to do the apply exponents, you need negative exponents, go back and review. And then 3 to the -1 is 1/3, 3 to the 0 is 1, 3 to the 1 is 3, and then 3 to the 2 is 9. Okay, so this will be the parent function, y equals base 3 to the x power. All right, so y equals 3 to the x power. Okay, so now let's look at what happens when we translate this function. Well, remember we were paying attention to our x values. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and then the same thing happens on the other side. So wherever we had an x value of 1, right, it's now going to be cut in half because if we have 2 over 1, right, the opposite is half of that. So 1 over 2, the reciprocal. So x is going to be cut in half. So now x is going to become 1/2. And where x was 2, now x is going to become 1. Okay, and then the same thing over here where x was -1, it's going to become at the same y level. So notice that your y values aren't changing, just your x values. Then that's going to become 1/2. And then where it was at 2, the the 1/9, right? Positive 1/9, sorry, that's going to become 1. So right here, it's going to be 1. So we can see that this function is shrinking, right? It's squished in. So basically, everything is going in this direction. So everything is being pulled closer, being pulled in towards the y-axis. Okay, so I hope this helps you with the dilations. The next video we'll do reflections, and then we'll do one on putting it all together. All right, thank you for tuning in. See you next time.